Hello, today we're going to look at binomial series. Some of this will look a little familiar from our probability unit. A plus b to the 0 power, that represents 1. A plus b to the first power is just 1a plus 1b. A plus b to the second power is a plus b times a plus b, which is a squared plus 2ab plus b squared. A plus b to the third power would be if I take this times a plus b. This might be a little tougher for people. A squared plus 2ab plus b squared. Multiply that by a plus b. I like to use my sneaky squares, especially once as these get bigger. A squared times a is a to the third power. 2ab times a is 2a squared b, and this would just be ab squared. This would multiply a squared b. This one would be 2ab times b, which would be 2ab squared. And then finally, it would be b to the third power. So we add up all the like terms, which would be 1a to the third, plus 2 plus 1 would be 3a squared b. 1 plus 2 would be 3ab squared. And then finally, we have 1b to the third. All right, if you look at this pattern, we have 1s on the outsides. We can get this value by adding the two values above it. So this looks like Pascal's triangle. A plus b to the n is called a binomial series or binomial expansion. Let's look for some patterns in the answers. How many terms are there? All right, so if our n value is 3, how many terms? 1, 2, 3, 4. If our n value is 2, there's 1, 2, 3. If it's 1, there's 2 terms. If it's 0, it's 1 term. So there's always one more than the number of terms. So it's always n minus 1 terms. What is the sum of the exponents in each term? If I add these two exponents, I get 3. If I add these two exponents, I get 3. I just have 3 and 3. This I have 2. 1 plus 1 gives us 2. So it looks like all of the exponents sum is just going to be that value of n. What happens to the powers on A and what happens to the powers on B? Well, A starts at the max. A starts at n and decreases by 1. Each term. B starts at 0. So starts at 0 and increases by 1 up until it gets to n. All right, so what patterns do we see in the coefficients? And we talked about this a little bit. And from our past experience with Pascal's triangle, hopefully you can see I'm getting the next term by adding the two numbers above it. So 5 plus 10 is 15, 10 plus 10 is 20, 10 plus 5 is 15, 6, and 1. So a plus b to the 7th. If I wanted to expand that, let's look back at our chart. We'd have to go out one more row, so it would be 1, 7, 21, 35, 35, 21, 7, and 1. So we'll look really closely at these numbers. So the first thing is we have 1a to the 7th. And we could say b to the 0, but that doesn't do much. Now our next term starts with a 7. So plus 7, the a reduces by 1, and the b increases by 1. So it's 6, and this one would be 1. Our next term is 21. So we'll have 21. The a decreases to 5. The b increases from 1 to 2. The next value is 35. The a decreases by 1. the b increases by 1. If I remember correctly, the next term again was 35. A to the third, b to the fourth, and then plus 21, a squared, b to the fifth, plus 7, a to the first, b to the sixth, and then finally b to the seventh. This is the expansion of a plus b to the seventh. So now 7 choose 0, that's 1. 7 choose 1, that's 7. 7 choose 2, if we look at this, it's 0, 1, 2. 7 choose 2 is 21. So this is just a reminder that these represent 7 choose 0, 7 choose 1, 7 choose 2, and so on. 7 choose 3, 7 choose 4, all the way up till 7 choose 7. So a way that we can write this as a formula, the binomial formula or binomial theorem states that if we have a plus b to the n, we can write it in infinite terms like this, where it's n choose 1, n choose 2, all the way up to n choose n minus 1, and n choose n, which is just going to be 1. That's our combination, and we can write that in series form right down here using sigma notation. We're going to take n and choose r, so we'll start at r equals 0 and work our way up to r equals n, and we'll take a to the n minus r times b to the r. And really, that's the same thing that we did here. We could write this as the sum as r goes to 0 to n equals 7 of 7 choose r, a to the 7 minus r, b to the r. If we look at any term, say if our r value is 2, we'll have 7 choose 2 times a to the 7 minus 2, which is fifth, b to the r, which is 2. So 7 choose 2 is 21. So it's 21a to the fifth, b squared. And that's the same value that we have here. So for r equals 2, we can find it using our formula, but it's the same thing that we got when we just expanded it. All right, so let's find the first 4 terms of x plus y to the 15th. Well, we'll have 15 choose 0, x to the 15th, y to the 0, plus 15 choose 1, x to the 14th, y to the 1st, plus 15 choose 2, x to the 13, y squared, plus 15 choose 3, x to the 12th, y to the 3rd. So there's a combinations button on our calculator. If I do 15, move over to probability. So I hit math, move over to probability. Number 3, 15 choose 0 is 1. So this is 1 times x to the 15th times 1. So that's just going to be x to the 15th plus. Now if I hit second enter, it will all pop up again, and I can just change the last number to 1. So 15 choose 1 is 15. X to the 14th, y to the 1st, we can just write as y. 15 choose 2 is equal to 105. X to the 13th, y squared. That's supposed to be a 13. And that's supposed to be a 2. And then finally, 15, choose 3. 455, x to the 12th, y to the 3rd. There's supposed to be a 3 there. So these are the first 4 terms in this binomial expansion. Try this one on your own. Try the first 4 terms of this binomial series. It would be a to the 24th plus 24, choose 1, a to the 24th, negative b to the 1st, plus 24, I'm messing it all up, plus 24, choose 2, a to the 23rd, negative b squared, plus 24, choose 3, a to the 22nd, negative b to the 3rd. All right, so this would be a to the 24th, plus 24, choose 1 is 24, a to the 24th. Now times b to the negative 1. So that would make this whole thing negative. So instead of a plus, we would want to write a minus, or subtraction sign in here, a to the 24th, b. 24, choose 2. Now I don't know that answer. I could do second enter again. Replace this 2. Turn this to 24. 24, choose 2 is 276. A to the 23rd. Negative b squared would just be positive, so we can keep the positive sign. But keep that in mind here, because we have negative b to the 3rd power, which would be a negative. And 24 to the 3rd power, (2024), a to the 22nd, b to the 3rd power. Now use the binomial theorem to expand x plus 3 to the 4th. Well, we'd have x to the 4th plus 4, should have written in subscript, 4, choose 1, all right, 4, choose 1 times x to the 3rd times 3 to the 1st plus 4, choose 2, x squared, 3 squared, plus 4, choose 3, x to the 1st, 3 to the 4th, and then finally 4, choose 4, which is 1, x to the 0, which is 1, times 4, or that's 3 to the 4th. All right, so we have equals. X to the 4th is simplified as it can be. 4, choose 1 is just 4. 4 times 3 would be 12, so that would be 12x to the 3rd. 4, choose 2. Let's see if we can bring this up again. Four, choose 2 should give us 6. So let's check it out. Yeah, that'll give us 6, and 6 times 3 squared, which is 9, should be 54. X squared plus 4, choose 3, which should be 2, or 4, choose 3, which should be 4. So it would be 4 times 3 to the third, I see I've made a mistake there. 3 to the third, which would be 27, so times 27, which is 108x plus 4 choose 4, which is 1, times 3 to the fourth, which is 81. So x plus 3 to the fourth is x to the fourth plus 12x to the third plus 54x squared plus 108x plus 81. All right, try this one on your own. A minus 4b to the third. Pause it. When you're ready, start it back up. This would be a to the third plus 3 choose 1, a to the second, negative 4b to the first, plus 3 choose 2, a times negative 4b squared, plus 3 choose 3, which is just 1, times negative 4b to the third power. So this would be a to the third, 3 choose 1 is just 3, times negative 4 would be negative 12. So that would be negative 12, a squared b. Negative 4 squared is 16. 16, 3 choose 2 is 3. 3 times 16 is, I'm guessing it's 48. I should probably do that on the calculator. It's 48. That's ab squared. And finally, 3 choose 3 is 1. Negative 4 to the third power is negative 64. B to the third power. All right, one more. 2a minus y to the fifth. We have 2a to the fifth. Now, if we think about the fifth, I think instead of doing the combinations, one thing that I think is easier is using Pascal's triangle. The fifth row, we have 1, 5, 10, 10, 5, 1. And we can use this row to do each part of this. So 1 would be multiplied by this. Then 5 times 2a to the fourth times negative y to the first times 10, or plus 10, times 2a to the third negative y squared plus another 10, that's this 10, times 2a squared negative y to the third power plus 5 2a to the first power times negative y to the fourth plus 1 times negative y to the fifth. So when we multiply this all out, 2a to the fifth, 2 to the fifth would be 32. So a to the fifth is just a to the fifth. Now this next one is, we have a negative y in here. So negative times 2 positive is going to be a negative. And we have 2 to the fourth, which is 16. 16 times 5, which is 80. So it's minus 80. A to the fourth, y. Here we have 2 to the third, which is 8. 8 times 10 is 80. And y squared is going to be positive, so this is another 80. Now it's a to the third y squared. Y to the negative y to the third would be a negative y. 2 squared would be 4. So 10 times 4 would be 40. And that would be a minus 40 because of the negative in front of the y. This term, we have 5 times 2, which is 10. The negative is to an even power, so it would be a positive. So 10a y to the fourth. And then this would be minus y to the fifth. And there you go. And here's the homework for tonight. Good luck.